Here we're here to talk about classic British motor cars. We have a new project, and it's, as you can see, a Morris Minor. And this is actually one a car we wanted to do for a while. And I think we've wanted to do it because this kind of era of British car, there's a certain way they're often modified, and it's not the way we want to modify it. It's probably the best way of saying it. They tend to retain far too much of the original mechanicals, which are really, how can I put this politely? They don't show their age well, let's say. And to be honest, the design, when you actually look in detail at the design of all the suspension components, they are terribly designed. There's no polite way of saying it. It's just an awful bit of engineering. But what we like about it is the fact that it's just such an iconic car. I mean, how many people have a story about their dad driving one, or they learnt to drive in one? You know, it's just a car that kind of really sums up a particular era of British motoring, and I love that. You know, and I love, in a way, the look of them. But they're just, the driving experience is just miserable. And of course, people look back with rose-tinted glasses, saying, "Oh, you know, they were lovely little things to nip about in," and which was probably true when the average speed on the road was about 30 miles an hour. But if you actually study everything from an engineering point of view, everything is atrocious. You know, the way the suspension is designed on it is just not really acceptable. And I'm amazed that it was considered acceptable back then, to be honest. I mean, a great example is the way the steering works is basically a male thread rotating within a female thread. And in the bottom knuckle, that female thread is inverted. It's basically a cup like this, which has a seal around the top of it, which inevitably is either old and perished, or a new replica made in China very cheaply and perished when it was already new. And you get all the road grit and water basically washing down inside this closed female cup. So when you're steering, your steering is rotating a male thread in a sort of grinding paste of road grit inside a female thread, which inevitably just wears that thread away. And when that thread does wear away, the spring pressure's on the lower arm, and it just pops the whole thing off downwards, and your wheel just flaps off to the side, and probably you crash. And the whole thing, and that basically carries on when you look at all the rest of it. You know, the upper mounting of the upper suspension arm is a lever arm damper, which is woefully inadequate in terms of locating the wheel in a secure way. So yeah, what we really wanted to do when we were approached about doing a Morris that drove well was totally start with a clean sheet. You know, think about what we want to retain, and what we want to retain is the look of the car. Not to say we don't want to enhance that, but that is really the thing that we're trying to capture here, is a car that looks like that but is nice to drive. So moving on from that, we thought, well, okay, we want to get rid of all of the original Morris mechanicals. What options have we got? You know, I know the customer wants it to be nice to drive compared to a modern car. Wants it to be reasonably quick. It doesn't have to be stupidly fast. This is not a motorsport build. It's not a drift car. It's just something that it wants to be used at a reasonable pace on the road. And we thought, well, we could design our own suspension completely. But quite often you'll find that there are existing suspension designs that you can kind of transfer over from another existing vehicle that does the job. You've just got to be wary of falling into a pitfall where you think, oh yeah, we'll just swap this subframe in, and actually there's that much work involved in making it fit that you could have just engineered it from scratch in the first place. So our thinking was, well, we'll have a look at the options. What cars are there that could donate the subframes that are a similar weight? They drive in a pleasing fashion. Front engine, rear wheel drive, that have a similar wheelbase and a similar track width. And actually the list is quite small when you look at it. An obvious one that springs straight to mind is Mazda MX-5, which, if you've ever driven one, is an absolutely amazing car to drive. They feel underpowered, and that's more because of how competent the chassis is, that you feel like you could put a lot more power in it. They're not particularly underpowered, they just feel the chassis is so capable, you think you could have twice the power in this and it would still be absolutely great. So we thought, well, MX-5, what's the track width like, what's the wheelbase like? We knew we wanted to widen the bodywork anyway to give it a slightly more muscular stance, and so the track width worked out really well. And yeah, it basically all looked very favourable. The wheelbase is slightly longer, but we already knew cosmetically we would like to move the rear axle line slightly further back. If you actually look at a square on side view of a Morris, the axle line almost looks too far forward. So it all kind of added up. And then we thought, well, could we use all of a Morris drivetrain? Sorry, an MX-5 drivetrain? Could we use the engine? Well, it's an 1800 in the most powerful one. It's not a particularly powerful 1800, although it is a nice engine. And of course, we're building all these cars to basically be new at the end of it. So we would have to completely rebuild that engine to a new condition. And by the time you've done that, you've spent quite a lot of money on the engine. Is there a better option? And so we started looking at engines that we could basically get as a new built engine. And the obvious kind of direction to look in is Ford. We know we can get a Duratec as a new crate engine. We know we can get a Zetec. And actually, although there was a factor that would almost make you think a Duratec might make more sense, and that is that we wanted to retain the Mazda MX-5 gearbox. And of course, the third generation MX-5 had a Duratec in it. As you'll know, if you've watched the Murray build, we've used a third generation Mazda gearbox coupled to a Duratec because it mates straight up. But we really wanted the exhaust to be on the passenger side. We knew packaging was going to be challenging on this one. So we were thinking, well, the smaller the engine, the better physically, and it would be nice to have the exhaust on the passenger side. It actually probably makes sense to use the Zetec. And we're not after huge power here, remember. We were thinking from the start 200 horsepower, and this is going to be absolutely fine. That's going to make for a pretty rapid Morris Minor. And that's really the basis that we chose the engine. We can get it new, it makes the power we want. It's a proven engine, and all of the parts are available new. There's an existing off-the-shelf conversion to put it onto the Mazda MX-5 gearbox. The exhaust's on the side that suits us better in terms of packaging it around where the pedal positions are going to be. It just made sense, so we decided to go with an Omex-built 2-litre Zetec. This is a dummy engine that Omex have supplied us while they actually build the final engine, but the final engine is essentially a standard 2-litre bottom end with a few choice upgrades on it. A ported head, different cams, and their throttle body, individual throttle bodies, and then their ECU, which will make more, give or take, 200 horsepower. We then wanted to make that up to the Mazda MX-5 box, and one of the reasons that, apart from the fact we knew we could also already get an off-the-shelf conversion to put the MX-5 box on the Zetec, and that it's a really good rear-wheel drive gearbox, we also wanted to use the MX-5 backbone. Basically this piece here, which joins the gearbox to the differential. And that's one of the things that contributes a lot to that to the driving experience and basically the dynamics of the vehicle. It essentially eliminates any torque change, difference in torquing motion between the engine and gearbox and the diff. The whole lot are tied together as one unit. So all of the upwards torque reaction of the rear end is controlled completely by it being attached to the gearbox. And likewise, the rotational movement of the engine and gearbox is tied into the subframe. So the whole lot is basically mounted from your engine mounts and your rear subframe mounts as one fixed unit, which means, in the practice of driving it, when you accelerate hard, there's no kind of relative movement of the engine before the drivetrain takes up the load at the back there. It all kind of reacts as one unit and just makes the whole thing feel incredibly direct. I mean, if you've not driven an MX-5, it's definitely a car you have to drive. And it's just one of those cars where you don't even need the power because it's just fun extracting every last little bit of kind of life out of it, whether that's on track or just having a spirited drive on some country lanes. They are a fantastic thing. So yeah, that was the plan. it all kind of fell into place from there. That all made sense. So we thought, yeah, that's what we'll go for. We did some design renderings for the outside. We wanted to kind of give it a much more aggressive look. So we've come up with a redesign package where we're going to do wider wings on it, widen out the sills to match. We're going to redesign all of the front panel, some subtle redesigns on the back, and basically just give the whole car a much more aggressive stance. Also lower it a lot, but not really compared to a modern car. It's not going to be that low. It's just that as standard, these have a huge amount of ground clearance underneath them. We're going to be something like 100mm lower than a normal Morris, and we still have, I think it's 4 or 5 inches of bump travel. So it's not really low, super low compared to a lot of lowered cars, but it's certainly low for a Morris Minor. And of course, the beauty of doing the way we've designed this, where we're doing our own sort of chassis with Mazda subframes, is that we can actually mount them higher in the body. So in lowering it, we're not actually lowering the suspension relative to the subframes and upsetting the geometry. We're going to keep that exactly as per standard Mazda MX-5. All we've done is mount those subframes higher within the body, so that the whole body sits down lower relative to the road. Now the way we've decided to go about installing these in the body is basically to jig the shell to make sure everything's square there, cut the whole lot out of the underside of the Morris. We've made jig fixtures to then mount the 2 subframes exactly in position where we want them. And then my brother, who's the chief engineer here at Retro Power, is basically designing the chassis for it. So he's designing a tubular backbone chassis that then ties into the outer original sill structure to basically create a perimeter. Now he'll go into that in more detail in probably the next episode about this project. But yeah, essentially that's the fundamental design, is a steel backbone using the Morris sills as the outer perimeter. We're tying it in various other places, and then we'll do steel bulkhead I believe at the front, and then a lot of the infill, for instance on the tunnel as it stands at the minute, we're planning on probably doing composite panels. So we'll do moulded carbon fibre panels to infill a lot of these sections where it's not particularly structural, although they'll be bonded and therefore provide a lot of structure anyway. But they're just areas that need infilling, so you're not open to the road, of course. So that's pretty much the fundamentals. Packaging everything is always going to be the challenge on this. The seat was one of the early things we looked at, was being able to fit a seat in here and get the tunnel in here, and a big enough tunnel to actually take this original MX-5 backbone. Kind of makes you realise how well designed the MX-5 was originally, and they packaged everything in. But that's all looking good. We've just been offering up the pedals just this week to get the driving position kind of set and make sure we've got space for everything and work out the exact shape of that front bulkhead. And that's basically where we're at. So yeah, really cool, exciting project. Very happy to be a part of this. Basically recreating a British icon, but with the performance to really do it justice. We'll try and keep you informed as we progress through this. Nat will take over next time and go into a bit more detail about the chassis engineering on it, because that's beyond really my scope of knowledge. And yeah, we'll go from there. We'll see you next time.
Cheers.